All right, so this video will focus on 3.1, and the very first thing we're going to do is kind of review from the last book, or last chapter. If we look here, I want you to pause the video and try to solve for x for each one of these, and then press play and see if you got it right. So our essential question is, how can you describe angles formed by parallel lines and transversals? So let's first define what these things actually mean. Right now, parallel lines, of course, are just two lines that will never cross. They're set at the exact same angle, so it's like train tracks in a sense. They will never cross. They'll go on forever in both directions. Then I have this line that goes through, and that's called the transversal, and that cuts right through both of these parallel lines. So that's what a transversal is called. And it says how many angles can be formed by parallel lines and transversal. If I look here, just with these parallel lines, I have two of them, right? And then for each line, when I cut this transversal through, I have one up here, 2, 3, and 4. So a total of 4 per line. Since I have two lines, that means I have a total of 4 plus 4, or 8 total angles. Which of these angles have equal measures? If I look at it, this angle up here, this like V, it's nice and wide. It's an obtuse angle. And that looks kind of similar to this one down here. This is also an obtuse angle. And they actually have the same measurement. It's called a vertical angle. This one here is an acute angle, and then directly across, that is also an acute angle. Now what's kind of neat about these transversals is this angle up here is exactly the same as this angle down or here. Notice how this is also an obtuse angle? Since they're parallel lines and they're cut at the same angle, this will be the exact same angle as whatever this is up here. Similarly, if I look down here, this angle is the same as this angle down here. So once I know one angle, I can kind of figure out the rest. This says if you have this construction task and I want to figure out if these lines are all parallel to each other, how can I figure that out, these studs? Well, since I have this diagonal that cuts through all of them here, I could look at the angle measurement between the stud and this transversal or this longer piece, and they should all be the same angle between them. And that's how I can tell if they're actually the same or not, or parallel to each other. So then let's actually do one of these and see how it is. So it says identify the parallel lines. The parallel lines are right here, line K and line L. The transversal is line M. How many angles are formed by the transversal? As I said before, there are 4 per line. Since I have 2 lines, I have a total of 8 of them. And which angles are congruent or the same? Well, if I look here, angle 8 is the same as angle 3. Angle 8 is also the same as angle 6, which is also the same as angle 1. You see how they all look the same? Now pause for a second, try to figure out what the other angles are that are the same. All right, so now you've had a chance to reflect. You should have seen that 5 and 2 are the same, as well as 7 and 4. Those are the congruent angles. And basically a transversal intersects parallel lines. The corresponding angles are congruent. So we can tell here that this one here is congruent to this one down here. You see the red? And then again, like I said before, these red are congruent to the green down here, right? They're the same angle measurement, which is also the same from down here. This one blue is the same as this one over here. But as we said, it's also directly across is the same. So here's an example. Now I have 110 here, and we know that any straight line is equal to 180 degrees. So let's just very quickly take this and let's go through and do this. I was trying to copy it over. But if this is 110, I know that this other one has got to be 70. So let's put that down. I'll put down 70. And if this is 70 here, because the total line equals 180, that means that this here is 110. That means that this inside angle, if this is 110, that means that this is the same as this angle here, right? So that would be a 70 for angle 2. And 70 plus what number equals 180? Well, 110. This right here is 70. And again, the way that I can tell is that from here to here is 110, so from here to here is 70, right? Because it's 180 altogether. If this is 70 here, that means the other side of it must be 110. So as you see here, there's like a big circle. I have my 70, my 70, my 110, and my 110. And this is a 70, 110, 110. So what do you think this might be here? That's right, 70. So then if I look at this one here, I have my angle measurement being 63. Now, which are the same angles as 63? Angle 1, so we'll put down 63 down here. These are the same. And then directly across, we call these vertical angles because it makes like a V. You see that? So this is also a 63 right here. And a vertical angle here is 63. Now, how do you think I figure out this obtuse angle? What would I have to do? And the answer here is I actually go through and I figure out 180 minus 63. What does that equal? And so I'll get 7. So I'll get 117, right? And if that's 117, then the vertical angle here is 117. And this is 117. And this is 117. That's how you kind of go through and do these. We're going to keep doing the same thing. So as I go through, pause the video, try to figure out what these are. So these are 75. And of course, 75. So I have angle 6 is the same, angle 4, and angle 1. And then I have to figure out the supplement. So what will equal 180? And 180 minus 75 is 105. So angle 2, angle 5, angle 7, and angle 3 are all 105. So there's another one, try to figure this out. So I know this is 59 here. What would this equal up here? Pause the video, try to figure this whole thing out. All right, here you go. This one here says the store owner places a piece of tape on to paint a window. The letters are slanted at an 80-degree angle. What is the measure of angle 1? So if this is 80 degrees right here, I have to think about what the other side of this would be if they're parallel, right? They're parallel lines. So this side has to be 100 degrees. If it was 65, I would just take 180 minus 65. I get 115. So the key idea here is that we have alternate interior and alternate exterior angles. Notice how this up here, these two, are the exact same as these two down here. And this one is the exact same as this one here. Those are my exterior angles. You'll notice also that they're obtuse angles, right? So I have obtuse and then my acute. This is my obtuse and my acute. And these will match up, and these will match up. They'll be congruent. The interior has the same exact thing happening. You'll notice it's the opposite. So on the inside here, notice how it was acute. That's what this is up here, acute, which means the inside one has to be obtuse. And if this is obtuse here, that means that this would also be obtuse. And the same thing goes on, which is what I have shown. So it says, describe the relationship between each pair of angles. So I have angle 3 and angle 6. So here is angle 3 and here is angle 6. These are alternate exterior angles. So they're exterior, but they're alternating because they're on the opposite side or opposite parallel, right? One's in the lower left, one's in the top right. 2 and 7, if I look at them, if I have these two lines, you'll notice that they are on the inside, right? And they're going to be alternate interior angles. And then it says in example 4, so it's 84, find the measure. So if this is 84 degrees, which one is 84? Angle 3 is 84 degrees. So if I go here, 84, that means that this has got to be 180 minus 84. So that's 96. And so on. And basically that's the lesson today, just finding just the various angles. And if we know 180 degrees are straight lines and we know one angle measure and we have a transversal, we could very easily figure all this